Okay. There are two things that are certain in life. You know what they are? Death and taxes.
Nice.
Okay. And we're going to talk about this a little bit later in the lesson, but an example that we're going to use sort of throughout this lesson, actually we're going to use the salaries from the previous lesson as the main example, but we're also going to talk a little about taxes in the States, because when Donald Trump was first president, they managed to pass a big bill that him and his party were saying were good for everybody. Everybody's getting a tax break. Whereas the other party, Democrats, said no, everybody's getting the middle class or lower class, they're getting very small tax breaks, and it's the rich people that are getting all the tax breaks. So we're going to talk about that a little bit later when we compare a couple of graphs. Now, in the last lesson, we talked about how to find certain measures of center and variability, specifically the median and the interquartile range. Okay. We also talked about a couple other measures, mean and standard deviation, but we're not going to worry about those right now. Because we use median and IQR specifically to actually calculate outliers in data. Because remember, up to this point, we've kind of been looking at data, like looking at numbers or looking at a graph and saying there appears to be an outlier, or there appears to be several outliers, or whatever. We can actually calculate, okay? And this is how we do it. So just as a reminder, we found all these values, okay, in the last lesson. We talked about how to find the median of those salaries, how to find the minimum and maximum, which are pretty straightforward, how to find the first and third quartiles, and from that, get the interquartile range, or the IQR. Do you remember how to find it? Third quartile minus the first. That's right. Q3 minus Q1, which in this example gave us 7. So you need the interquartile range to calculate outliers. Now there's two types of outliers. They could be on the low end of a distribution, or they could be on the high end. So what we have to do is we have to calculate an upper limit where anything past that is an outlier. And then we calculate a lower limit when anything lower than that is an outlier. And this is how we do it. For the upper limit, we take the value of Q3, which we found was 41, plus 7 times 1.5. The IQR times 1.5. And we calculate that value. And when we do that, we get 51.5. Anything higher than 51.5 is an outlier, specifically an upper outlier. When you look back at your distribution here, is there anything above 55? Yes, there are 2 values. Okay, so we would say 67 and 185, or remember, these are in terms of money, 67,000 and 185,000 are outliers. Specifically upper outliers, but you don't have to use that word. You can just say are outliers. But now I got to calculate the lower. And to calculate the lower, you take the value of Q1, which is 34, minus the IQR times 1.5. And when you do that, you get 23.5. Anything lower than 23.5 will be considered an outlier as well, specifically a lower outlier. Any values? No. So, I mean, there's no lower outliers. So that's how we would calculate outliers. So in order to do that, obviously you need the distribution of values, okay? And you need to be able to find the IQR. Sometimes you're going to have to go through the list and actually find Q3 and Q1 and subtract them to get the IQR. Sometimes it will be given to you, Q1 and Q3, okay? Let's see if I can find an example. Another thing that we can do with median and IQR and max minimum, otherwise referred to as the 5-number string, we can create a certain type of graph called a box plot. Okay. Now, this isn't based on the previous example. This is just a new example. Okay. So what we do in order to do this is we have a horizontal axis with the values, and then there's certain sections where there's outliers, there's Q1, there's Q3, there's the median, there's the minimum and the max. If you've got dots or stars, those are considered outliers. So, outliers. Not only is this one an outlier, it is also the minimum. Where would the maximum be? The far right side of the box plot. If there are any outliers, if not, then this is the max. So this here is the max. Now we focus on the box. Okay. The vertical bar inside the box will always represent the median value. And the left and right ends of the box will be the values of Q1 and Q3. So you can see that it appears that, I don't know, 0.4 and 0.8 or 0.9 in this are outliers. 0.4 is also the minimum. Q1 looks like it's about 6.5. Median looks like it's about 8.2. Q3 looks like it's a little under 10, so maybe 9.9. And the maximum, a little over 13.5, 13.6 or 13.7, 6 or 7. Like it's on. Never mind. I don't know why this is coming up so much all of a sudden. It's weird.
Maybe it's supposed to be.
Like when it worked. That's the second time I've done that today. Did that in pre-prop too. Yeah, maybe it's always been there and then just noticed it. I don't know. Okay. So like the other graphs, quantitative graphs, like histograms, dot plots, and stem plots, right? We can actually get information out of box plots. So by looking at the graph itself, looking at this one, looks pretty symmetrical here, right? Like these look pretty much the same. This is pretty much in the middle of Q1 and Q3, although there's an outlier. How would you describe the skew, or would you say roughly symmetrical? I would say roughly symmetrical, or if anything, maybe a slight left skew because of the outliers. I would accept either one. Okay? These ones are a little bit more obvious. What would this one be? The shape, right skew, definitely. A solid right skew. Similarly, this one would be a solid left skew. And notice we can also find, you could state the measures of center, find the median, which will be the vertical bar inside the rectangle. We could state the variability. How do you state the variability? IQR. Do you find the difference between those two? We could state if there's any outliers, because in box plots, it's obvious because they're starred or circled. Okay.
Can it be both lower and upper limits?
Sure, absolutely. Okay. Okay, so going back to our salaries example, something that you should be familiar with. What percent of the data is below Q1? Look at it. Look how it's split. What percent? 25%. Yeah, over. What percent, be careful with this, is below Q3? 75%. Because 25% is above, which means 75% must be below. What percent of the data is above Q1? 75% again. What percent of the data is above the median? 50. And what percent of the data is within the IQR? 50, right? Because this is 25, this is 25, which means in here it must be 50. Okay. Yeah.
The percent above, the percent of data above the median would only be
50, but yeah. Same with below. Okay. So I could ask you a question like, or you could be asked a question. The college board exam question would be, looking at this distribution of numbers, 75% of the data is between which two, or is, yeah, between which two values, approximately. 75% of the data. Actually, I need to be a little bit more precise, don't I? Because there's multiple answers there. Okay. 75. In what two values is it below 75%? Is it below 25% of the data? Between what two values is it below 25% of the data? What two values is below, between what two values is below 25% of the data? Well, here's 25%, right? Yeah. So below that, between which two values, 29 and 30, you would say, right? Or I would say true or false, 75% of the data is between 34 and 185. True or false? That's true. Okay. 50% of the data is between 29 and 39.
Oh,
That's false. Okay. So don't be surprised to see something like that. Okay. Here is the actual dot plot, or sorry, box plot for the salaries example. Okay. Remember, we did calculate these. We calculated the median. We calculated Q1 and Q3. We know what the minimum is. We know that there's two outliers, the upper outlier being the maximum value as well. So we want to describe the distribution. So a lot of times you may just be given this, or you may be given this, and then a bunch of measures of center and variability listed below. Okay? When that happens, use the numbers in that table you're given. Don't use the graph. If you're told the mean and median, use those to describe center. Don't just ballpark it here when you're given them exactly. All right, so shape is what?
that's true.
Really?
No, it's.
Yes. You know where the center's at. Where's the center of the data at? Remember, you can use median or mean, whatever one you're given, if not both. We calculated the median. What was it? I mean, on the graph, it's here. But didn't we actually calculate it?
No.
Like look on page 1 of this lesson. Or page 2. Yeah, the previous page. You're given all those values. Yes, but in context, it's 34,500. Variability. In this case, IQR is, what was it? 7,000. And outliers? There are two.
Yes.
But there are two outliers. 67,000. I think that is right, isn't it? 67. Yeah, and 185,000. Remember, you also have to write in context. Okay. Okay, going back to the tax cuts. Here's an example of two different tax cut plans. And if you were to take all the values in each of them, okay, and find their mean or their average, their mean or average would be the same. Okay? But clearly, the distributions are not the same, right? Because in A, we have, first thing you should notice, in A, we have no outliers, but in B, we have multiple upper outliers. And in B, the median tax cut is quite low, whereas in A, it's higher. Okay? And then we could talk about the IQR as well, things like that. So remember, I referred to this in a previous lesson. So when we do this, we want to use the 4 components that I use the word SIVO to remember. Shape, center, variability, outliers. And then use comparative language. So one distribution is something skewed or roughly symmetrical, while the other distribution is whatever. The median or mean of one distribution is this, which is greater than the median of the other distribution, or which is less than the median of the other distribution. So let's just compare these two distributions. What would you say, and again, I don't mind if you use bullet points, how would you compare the shapes?
A is roughly symmetrical,
Continue.
while B is a right straight.
Right.
Here.
A is roughly symmetrical. Well, B, I mean, I would even say is heavily right skewed. Or significantly right skewed. Okay. You actually know a couple of measures of center, don't you? What are their means? Look at the question. What are their means? Yeah, 1260. So their means are equal. So the mean of each tax cut plan is equal, but the median of which one is greater than which other one. Now you got to go to the box plot. The median of A is quite a bit larger. So the median of A, and you can even include a ballpark value, looks like it's around, I don't know, 1800, is greater
It's not here on 14.
Oh, sorry. Yes. It's greater than B, which is approximately, I don't know, 300, 200 to 300. Okay. Okay. Variability. Which one's more spread out? Well, I don't know the standard deviation, so I can't compare that. But I do know the IQR, approximately. Which one looks more spread out when you look at their IQRs or the ends of the rectangles? A is more spread out. So A, IQR approximately looks like 2,000 minus 500, so approximately 1,500 is more spread out than B. Whose IQR is much smaller at approximately, we got about 500, almost like zero, we'll say 500 minus 100. So approximately 400. Sorry, I should have given you more space here. And finally, the outliers. That should be pretty obvious. There are no outliers in A. While B has multiple outliers. So given that, we can make some conclusions. Which tax plan shows tax cuts that benefit a broad number of the American population? A. Okay. A is a broad swath, where B benefits a small minority. Okay. And you can tell by the rectangles in the box plots. And the outliers in B. Those in combination make it pretty clear. And this last one's a good question. How is it that the means are the same? How would you describe that, or how would you answer that? The medians are very different, but the means are the same. So the means, what was it, 1260? So somewhere around there are the means. You would think that the means of B would be small, but what's pulling the mean up? All these, right? Because the tail, it's pulling the mean up. So here it's roughly symmetrical. So mean is about in the middle of the distribution. But here, even though the median's over here, the mean is way to the right because these outliers are pulling it up. Okay? So that's how we would answer it. You should be familiar with how to answer something like this. Okay? So the outliers in B pull the mean higher even though the majority of the distribution in B is below 1260. Because if you look at that box plot where 1260 is and where I drew the green dashed line, okay? Like a huge chunk of the distribution is below. Just really the outliers are above. Okay? So you can see, going back to the Republicans and Democrats, why Trump and the Republicans would want to say, oh, well, hey, the average tax cut is $1,260. So everybody's getting a tax cut. But the Democrats would say, well, hold on. The only reason why that average is so high is because all the rich people are getting huge tax cuts. So it's pulling the average up, where in reality, a huge percentage are actually getting below 1260. So you can see how statistics can be used to shape an argument. Okay? Which is exactly what happened in the States. They're still arguing about it today. You know, all you hear Democrats say, oh, the only reason the tax cuts benefit the rich. And the Republicans are saying, oh, we had one of the biggest tax cuts in history. I'm not going to worry. I'll let you look at the, we kind of talked about that in the discussion. Okay.